Our based Penguin OS supposedly just got a hell of a lot faster from a change that was made to a single line of code. Intel, the chip company that's been in a world of hurt for years now, revealed the results of a benchmark that shows a 3,889% performance increase in the Linux kernel after a fairly simple patch was applied to it. So that would mean a 40x performance increase for Linux users, essentially for free, because this is a software change. It doesn't require you to go out and buy anything new. Now, this is the initial post that was made to lore.kernel.org, and you can see that this was posted by a user named Kernel Test Robot, which is an automated service that Intel has been maintaining for per-kernel commit patch testing. Anyone who uses a bleeding edge system like Arch will tell you, at least after they finish showing you a screenshot of their tiling window manager and anime wallpaper, that Linux is constantly getting updates. Some of those patches increase the overall performance, some make it worse, and some have no effect at all. Plus, a change that's made could have different impacts on different kinds of workloads, so if people had to manually do all of that benchmarking themselves every time there was an update to the kernel, Linux users wouldn't be able to get any real work done, like patching DWM or searching for new anime wallpapers. Now, if we take a look at the details of the test that Intel ran, the test case was, will it scale per process ops on a machine with multiple Intel Xeon processors, 4 to be exact, for a total of 224 threads, and the machine was given 192 gigabytes of memory. So right away, this gives us a clue about what kinds of workloads this might assist with. This update probably isn't going to give you a huge FPS boost in your favorite video game because, for one, your graphics card tends to be what matters the most for anything related to games, but also, if you look at the processors that come pre-installed in gaming rigs, they definitely aren't multi-socket Xeon processors for one, but even the best gaming rig processors tend to favor higher clock speeds instead of more cores as far as the desktop lineup of processors is concerned. But Linux is seen by most people as a server OS first, and that's how it's primarily used, so it makes sense that the test rig in this case is a server and not a gaming PC or even a desktop workstation. So if we take a look at the commit that's actually responsible for this performance increase, nmap limit THP alignment of anonymous mapping to PMD aligned sizes. The THP stands for Transparent Huge Pages, by the way, which is a memory management feature that allocates larger blocks of memory at a time, which can translate to a performance boost to certain kinds of processes that are able to take advantage of that feature. The message goes on to say that since this commit, a mmap of anonymous memory without a specific address hint and of at least PMD size will be aligned to PMD so that it can benefit from a THP backing page. However, this change has been shown to regress some workloads significantly. And we have a reference to a bug report that was made in OpenSUSE Tumbleweed titled Kernel 6.10 THP Causes Abysmal Performance Drop. The bug reporter mentions that they regularly run spec CPU on a number of machines for compiler benchmarks, but the most recent update, which included a kernel upgrade, saw a performance drop of 600% in CAC2B SSN and other benchmarking tools. The bug reporter included a tarball with the test case that they were running so that other people could test it on their machines, and one user mentioned that they experienced about a 50% performance drop, which isn't as severe as OP's, but it does still confirm that there's actually a bug here and not just the OP imagining things or running their benchmarks wrong or something like that. It's also worth pointing out that the OP had a 600% performance regression on an AMD EPYC system, and the person who confirmed the issue with a 50% hit to performance was running the test on an Intel system. So it's not even just an issue with a particular chipset. So we've got it confirmed at this point that there is a performance issue in the kernel, but at this point, the problem has only been produced in benchmarks and not any real workloads and applications that people actually use. But then a few weeks later, there was an issue reported in the Darktable program. This is a free and open source photography workflow application, kind of like Adobe Lightroom, even though they say right here that Darktable is not a free Adobe Lightroom replacement, but that's the mainstream software that I think is most similar to Darktable as far as I know. Now, going back to the bug report, the OP here is reporting about a 25% decrease in performance when converting raw images to JPEGs in the 6.10 kernels compared to 6.6 kernels. Now, a 25% regression doesn't sound as bad as what the OpenSUSE benchmarks were reporting, but with a program like Darktable, you're rarely going to be making changes to one image at a time. You know, this isn't a Photoshop replacement, it's not a Lightroom replacement. So taking a 25% performance hit per image that's processed, if you're trying to process, say, thousands of images, is a massive problem. Now, unfortunately, the OP didn't get much help from the Darktable's developers when he mentioned it on their Git page, but since they managed to isolate the problem to a change in the kernel, they decided to reach out to the kernel developers in order to get some help. Now, at this point, the OP is thinking that the issue might just be related to AMD chipsets because they've only been able to reproduce the issue with Darktables on an AMD system, but not on an Intel system, which is kind of similar to what we saw with the benchmarks in OpenSUSE, except that Intel was still having an issue just about 10 times less severe than the issues on the AMD EPYC system. So regression testing on the kernel was done with bug bisection, and that commit that we looked at earlier was tracked down as the problematic code change. This bug report made its way over to the Linux kernel's regression tracker, and at first, the problematic commit was thought to be one of those things that might have made things faster on some systems and then made them slower on other systems, which would be fairly normal because, again, different workloads on different systems are going to perform differently. But then the first response came from someone on the OpenSUSE bug tracker who confirmed that it wasn't just an AMD thing, since the benchmark they were running on Intel systems were also noticeably impacted, but again, not as much. So the theory that they came up with is that there are many largish allocations that don't have individual sizes aligned to 2 megabytes that would have been merged. And this commit causes them to become separate areas where each aligns to its start at the 2 megabyte boundary, and there are gaps in between them. These gaps in VMA fragmentation itself is not great, but most of the problem seem to be from the start alignment, which together with the access pattern causes more TLB or cache misses due to limited associativity. And this same person here who responded in the bug tracker is also responsible for the headline grabbing single code line change that boosted performance by a whopping 4,000%. And this is the change that was made right here. They basically just added this additional check here to make sure that larger anonymous mappings are THP aligned. So while these headlines about huge boosts to performance in Linux are technically true, it's only going to really be true in very specific workloads on very specific systems, and the vast majority of us are not going to notice any differences. But I think the real bright side here is this entire process that shows us some of the benefits that you get with using Linux or any other open source operating system. You're able to do much more detailed bug testing and even bug fixing if you've got the knowledge to do that, beyond just clicking a button to report a crash in a program to Microsoft that nobody is ever even going to read. And if you're really, really smart, you can actually change the Linux kernel yourself to better suit your needs for whatever workloads you're actually running. It's like being able to swap the engine in your car to a V8 when you want to go fast, or a V6 when you want better gas mileage, or a diesel engine if you need to haul a whole lot of crap. You can do that with Linux, whereas on Windows, you're basically just sitting there in a Kia Soul at a stoplight waiting for someone to carjack you and then post their joyride on TikTok when they eventually total your vehicle. If you enjoyed this video, please like and share it to hack the algorithm, and buy some of my merch from my website, based.win, where you'll get a 10% automatic discount at checkout when paying in Monero XMR. Have a great rest of your day.